Hi there, Frank here. Seems that our journey has come to an end, so I'm not gonna make any other video about circuit analysis. And by the way, there are so many things that I haven't been talking about, um, well, like transistors, MOSFETs, as a matter of fact, and I haven't actually, or induction motors and how induction motors work, synchronous motors, um, and many other things. But as I said, and I also haven't been talking about, when I talked about things, I actually use like kind of loose definitions. Haven't go through, I haven't gone through, many formulas and so on because again, this mini series was supposed to be something to, help you, but in a sense of making you aware. It was a mini series that was supposed to be for making people aware of things that everybody should know and should be aware of. It wasn't actually supposed to be a mini series to fully help you with your exam and prepare you for your exam and so on and so forth because um, I haven't been covering many things. So yeah, this is pretty much it. But as a very last thing, um, what I want to talk about is what you have at home. Because, as a series, to make people aware of of how electricity works and how current works and so on, I couldn't really talk, they couldn't really end up the series without talking about outlets and what you basically have at home. By the way, I didn't even talk about reactive powers much. I have been making exercise, solving exercises, but uh, so anyway, um, outlets. Well, there are many different outlets, so I cannot draw one for each and every nation. So I'm gonna make a very generic one. It looks like an Italian one, but honestly, I didn't make it on purpose. It's just like a very generic one. So in an outlet, you're gonna have three holes. One is gonna be for the phase, one is gonna be the ground, and the last one is gonna be the neutral. Now the current um, gets in and flows from the phase to your appliance like hair dryer or your microwave or whatever, and then it goes back to the generator via the neutral. So let's just see, like, can go here, like power up my hair dryer. uh, it actually looks more like a gun than an air dryer, but that's because I suck in drawings. My drawing sucks. But so it basically gets out from the phase, go to your appliance, and then it goes back to the generator via the neutral. This is because, in order to have current, we need a closed circuit, and also for safety reasons. Because we're gonna have there are, well, I'm gonna talk about them. I'm gonna talk about this a little bit later. But anyway, so it basically gets out from the phase, go to your appliance, whatever that is, and go back to the neutral. Now, you may have noticed that your appliance, whatever that is, when you plug it in into the outlet, it may have only two to get to fill the holes. So you may be wondering, okay, those two are definitely going to be the phase and the neutral. So what happened to the ground, the third one? And what is the ground? Well, the ground is actually a third one and is there for safety reasons. But not all the appliances have the ground. The reason for that is that the reason for the ground to be there and actually exist is that if for any reason there is a fault in your appliance, and there is a leakage, then if there wasn't a ground and it was not connected to the ground, then as soon as you touch it, it will go, the current will go through your body and go to the ground. Therefore, you're gonna feel electricity flowing through your body and you're gonna be electrocuted. In order to avoid that, appliances do have a third thing here, which is connected to the ground. So if there is a fault, whatever that is in your appliance, instead of electrocuting you as soon as you touch it, then it's gonna go to the ground instead. Now, if your appliance doesn't actually have a ground wire, then it just means that, don't worry, it's not less safe. It basically means that the manufacturer actually made sure that it was already isolated. So for instance, my hairdryer doesn't actually have a ground wire because it's already isolated. It's made in plastic, and they made sure, well, by the way, plastic is a very good isolator to start with. And they also made sure that it was already isolated, so it didn't actually need a ground wire. That's why it only has a phase and a neutral. Also, for instance, my microwave doesn't have a ground wire. Now, I'm gonna tell you that there are many outlets and also plugs that you may see. This one, for instance, is a British one, and by the British one are the safest one for many different reasons. The first one is that when you plug it in like this, the phase and the neutral actually are like they're not completely exposed. So this is because they actually know that when you plug them inside an outlet, it only needs the very beginning of this to make contact. So instead of having all these exposed, like when you grab it and you have a loose, and you grab it like you have a loose grip, you don't have much grip, and for instance, perhaps you don't take it like this, but you take it like this, and you get out, you try to remove it from the outlet. You may touch live wires by mistake, but with this isolation here, you're gonna be safe. You're not, well, don't do that anyway, but technically you should be safe. And of course, there is also the ground. And here you can see there is a fuse. Let me see if I can just focus it. Crappy camera. Anyway, there is a fuse here, and the fuse is actually in each and every of this thing. So whenever you connect an appliance, and eventually it is the fuse that is gonna blow up. It's not the appliance. The fuse is actually like it really acts like something that's actually saving you from breaking your appliance due to any kind of thing, like for instance, if there is a huge spike in current for whatever reason. This one is about, well, I don't know if it's fused, but I don't know the value of it. Well, I could take it off, but anyway, it's about 13 amps, I think. But anyway, I'm not gonna look into it anyway. But I think it's 13 amps fuse. So if it exceeds the 13 amps, then it's gonna the fuse is gonna blow up, and it's gonna be basically your appliance. It's not gonna be damaged because of the fuse. Now let's go through some other. I have a German one right here. This one is a German one. As you can see, it's pretty different from the British one. It's from my microwave, as you can see, and it only has these two things, which are actually the phase and the neutral, and it doesn't have Hertz. You can see that it can have Earth, but it doesn't have it because it's made out of plastic, and I'm pretty sure that whoever manufactured it actually made sure that it doesn't actually need the ground because it's already isolated. I also have here this one, which is connected to a lamp, which you can see there. This one is actually an Italian one, and as you can see, this one only has the phase and the neutral as well, because it's basically just a lamp. So a lamp doesn't actually need, in this case, doesn't actually need, that lamp doesn't actually need to be grounded. So a ground wire. So, well, I do also have, what I want to show you as well is the outlet. Well, let me just get through here. So this is actually an outlet. As you can see, there is the phase, the ground, and the neutral. And as you plug things in, like this charger here, which only has the phase and the neutral, it's gonna work. And yeah, I'm just gonna go back like this. But what I'm actually interested in is the breaker. So this is very important. This is the breaker. This is called the breaker. The reason why it's called the breaker is that it actually breaks and open the circuits. Breaks the flow of current and open the circuits. The breaker is your best friend because these little guys here are actually magnetothermic relays. What does a magnetothermic relays do? Well, a magnetothermic relay in this case is gonna check that the current flowing from the phase and getting back from the neutral line those two currents are the same. If they're not the same, then that means that there's been a fault somewhere along the line. Therefore, the breaker is gonna break. And it's gonna close everything. So when you see this, turn it down. I'm not gonna do it. Well, I might. Yeah, I'm just gonna do this. Okay. So this is light. Light should go off like this. And then if I turn it back on like this, the lights goes back on. So this is the breaker. So as I said, it's constantly going to check whether the current that is flowing from the phase and going back to the neutral are the same. If they're not the same, it means that the current is always going to flow into the medium that has the lowest resistance. So for instance, if you touch a wire, the current then is going to have the choice whether to go back through the neutral or to go back through your body and to the earth. And of course, it's also going to choose your body. It's not going to go all the way back through the neutral. Therefore, the breaker, hopefully, is gonna don't rely on it exclusively, but hopefully is gonna notice that the current flowing from the phase and going back to the neutral are not the same, then it's immediately gonna open the circuit and break the flow of current. There is another thing, of course, which is actually well, my show. No, it's not. It's not very important, but anyway, there is something that pretty much everybody has in the outlet of the bathroom, which are actually different from the normal outlets. They're called GFCI. Let me just write it down. So let's get this guy here. Just so GFCI stands for ground fault current interrupter. Now, ground floor current interrupter. The reason why we have a GFCI everywhere, well, not everywhere, but in each and every bathroom, so restroom and so on, is because this guy here, well, the current, let me get back to my chair. The current that is actually needed to stop the heart of a human being is 30 milliamps. So 0.03 amps. The breaker, which we have there, is actually gonna make, is actually doing a good job into making sure that we don't actually, there is no leakage of any kind, and the current from the phase and going back to generator to the via the neutral is the same, but it may not be enough to save your life if you are like in the bathroom in soap water. So the reason why we have GFCI in our homes is that GFCI is actually actually with a kind of switch which is gonna detect constantly, they're going to detect very aggressively that the current from the phase is the same as the current going back to the neutral, and if it's going to detect that something is not going back to the neutral, so those two are different, it breaks and opens the circuit, but at about 15 milliamps, which is 0.015 amps, which basically means that, and don't take my word for granted because, but technically, if you are in the bathroom and you are taking a bath and you're bringing an electric appliance with you, and don't do that, please don't do that. But if you do, and that appliance actually is falling to the bath with you while you're taking a bath, and it's falling to the water, into the water, then you are actually going to feel a bit of current flowing through your body, but because it's gonna try to flow through the sink and all the way to the neutral, because the sink is grounded, to the ground, sorry, because the sink is grounded, but you're not gonna die. So this is actually why we do have GFCI, ground fault current interrupter, in the bathrooms. If you are in the UK though, there are not gonna be outlets inside the bathroom, just to make sure that people don't actually use any kind of electronic device into the bathroom, especially while they're taking a bath. But please beware that if you do have GFCI in your house, then they're probably only in your bathroom. So, well, my recommendation is not to bring anything with you while you're taking a bath, but if you are, at least please connect them to an outlet which is located inside the bathroom and that you are sure has the GFCI, because if you do actually connect it from an outlet which is outside the bathroom, then there is a chance, a high chance, that that outlet is not going to have a GFCI, and therefore the breaker may break the current. Almost definitely is going to break the current, but it's going to do that at 30 milliamps, which in the best case scenario is going to be extremely painful, but you're going to survive. In the worst case scenario, you're not going to survive, and you're just going to die. So yeah, just keep in mind that that always make sure that you do use GFCI if you are in your bathroom and you want to use appliances in your bathroom. So yeah, this is a very, 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 very high level overview about how electricity works in general. And I really wanted to end with this video because it's about something that people use every day, like your appliances. So yeah, that's pretty much it. And with this, I'm gonna say goodbye. And there is a chance I might be, making this a bit more detailed in the future and post new videos about the subject and so on if people are really interested. But I don't really think it's gonna happen anytime soon. So for now, I can actually say that this mini series about the very, very basic stuff about current is over. Thank you for everything and for following me. It's been a pleasure. Goodbye.